Very important problem from probability distribution of one dimensional random variable. And the problem is, if x follows standard normal distribution, so that half x follows gamma distribution with parameter half. Okay, so if x, this is normal 0 1, this is also called standard normal, we have to prove that half x square, this is gamma half distribution. We have to prove this. Okay, and here we first write the PDF of x, which is normal 0 1. We already write here the PDF. Okay, so we write, since x is normal 0 1, so PDF of x is given by phi x, this is equal to 1 by root 2 pi into e to the power minus x square by 2, and the range is minus infinity less x less infinity. And we know that for all the other distribution, PDF is denoted by fx, but for the standard normal distribution, PDF is denoted by small phi of x. For this reason, we write here phi of x. Okay. Now we try to use the transformation of random variable. To transform the random variable, here we let y, this is equal to half x square. Okay, and in real variable, we write y, this is equal to half x square. That is, the differentiation is dy dx, this is equal to x. Okay, and we say that this x is maybe positive or maybe negative, because our range of x is minus infinity to infinity. So the formula of transformation of random variable we cannot use here. Why we cannot use here? Here we already write down the transformation of random variable formula, which is given by this. But this formula is used only when phi dash x exists and gives the same sign for all x. But here x is positive or negative, for the positive and negative value of x. Okay, so we try to find out the PDF of y by another process. How to find out the PDF of y? To find out the PDF of y, we consider the definition of PDF of y. Okay, and which is given by probability of small y less than capital Y less equal to y plus dy. And we know that the definition of PDF is given by gy dy. Okay, where gy the PDF of y. Okay, now from the left side we write probability of y less than y less equal to y plus dy. This is given by, since we know that we can put here, this is probability of y means half x square, and this is less than, this is given by half into x square, this is a random variable, and the right side is given by less equal to half into y plus dy whole square. Okay, and by cancel out half from three sides, we get this relation. Okay, now we divide this problem into two parts. The first part, here we let first part of S1, if we let x greater than 0. Okay, because x is between minus infinity to infinity. Now if x greater than 0, we get this relation as probability of y less than capital Y less equal to y plus dy, and this is equal to, we write again this term, here we make a mistake, this is x plus dx whole square. dx whole square. Okay, so we get probability of x square less than x square less equal to x plus dx square, and by taking square root we get probability of, this is mod x and this is mod of x plus dx and this is mod of x. Okay, we get this relation. Now since here x, that is the real value of the random variable, is positive, so we write this result as probability of x less than mod x less equal to x plus dx, because x is positive, so x plus dx is also positive, so there is no need to give modulus. Okay, now we see that this relation hold in two cases. If we draw a real line, here mod x is less than x and this is less equal to x plus dx, and if this is 0, this is x, this is x plus dx, then we write this relation as probability of, since this is a set or this is an event, we write this is x less than capital X less equal to x plus dx. In this event, if x is lies between x and x plus dx, then mod x is also this. Okay, that is from here to here. Okay, also we get another event for this probability, that is we write here plus probability of, this is minus x plus dx less than capital X less than small x. Okay, and sorry, this is less equal to, this is negative. Why we write this? Because if capital X is lies between, here this is x plus dx, this is negative, and here this is x. For this reason, this relation or this event also satisfied. Okay, now due to symmetry of real line, here this and this event are symmetric, so the probability of these two events are same, so we write this relation as 2 into probability of x less than capital X less equal to x plus dx. Okay, and also we write this is 2 into, this is the definition of PDF of x, and which is given by, sorry, PDF here we let phi x, this is given by phi x into dx. Okay, so we write the left hand side definition. What is the left hand side definition? This is given by g of y dy, so we write here g of y dy. Okay, so we get g of y, this is given by 2 into phi of x into dx by dy. Okay, dx by dy, so we get 2 into phi of x, this means 1 by root 2 pi into e to the power minus x square by 2 into dx dy. What is dx dy? Dx dy is given by 1 by x, so we get from here, this is 1 by x. Okay, now we write y for the value of x to find out the PDF of y. So we write here g of y, this is given by 2 into 1 by root 2 into pi. Okay, and we put x square equal to 2y. Okay, so we get, this is e to the power minus x square by 2, this means y, and what is the value of x? X is given by, from here we get x is given by root 2y, so we put, this is root 2y. Okay, and root 2 and root 2 cancel with 2, so we get 1 by root 5 e to the power minus y into 1 by root y. Okay, and this is 1 by gamma half, because we know that root 5, this is equal to gamma half from the property of gamma function. Okay, and this is e to the power minus y, and this is y to the power minus half, and we write minus half in the form as half minus 1. Okay, and since here x is greater than 0 and the range of x is minus infinity to infinity, so here x greater than 0, this means 0 less x less infinity, and in this case we must write that 0 less y less infinity. So here the PDF of y is given by g of y, this is 1 by gamma half e to the power minus y into y to the power half minus 1, and the range is 0 less y less infinity, and this is nothing but this is gamma half distribution. Okay, because this is the gamma half PDF. We write here the PDF of gamma n variate, or if x is gamma n variate, then the PDF we know that fx, this is equal to 1 by gamma n e to the power minus x into x to the power n minus 1, and the range is 0 to infinity. So we get this is gamma half distribution.